Everybody. In this video, we are going to talk about expected value. And so we have this probability distribution, like we talked about in the last video, of flipping 3 coins and the number of heads that are present when we do so. And we want to find the mean, which is called the expected value when we're talking about probability distributions. And we're also going to find the standard deviation. And the standard deviation is actually called sigma when we're dealing with, let's see if I can find the symbol here. So that's sigma. So we're going to find the mean, which is called the expected value, which is given by the symbol mu. That's mu, mu, pronounced M-E-W, mu, of the discrete random variable. So we've dealt with x bar the whole time. We did talk briefly about population versus sample. But what we're doing here is we're using a sample to then generalize about the larger population. In this case, the larger population is theoretical probability. What would happen if we did this over large numbers of trials? So we're going to find the mean. To find the mean, this is done very similar to when we found the mean of grouped data. So the mean or expected value of a discrete random variable is given by the sum of all the x values times the probability of each x value. So we're just going to sum up the product of these two things. So in this column, we're going to do x times p of x. And just a reminder about spreadsheets, we really just have to make the formula once. So I'm going to hit the equal sign to start the formula. And we're going to take x times the probability that that x value happens. And we multiply those together and we get 0. And then we copy that down. And you can see in each of these, we're doing those two cells multiplied together, and then these two cells multiplied together, and these two cells multiplied together. Okay, so this says to sum up all these products. So I'm going to sum the products, and that gives me 1.5. So 1.5 is the expected value. So when I flip a coin 3 times, I should expect to get, on average, 1.5 heads each time that I flip 3 coins at the same time, which kind of makes sense. So now we want to find the standard deviation. So the standard deviation formula, this is the variance formula. So first we would find the variance, which is the sum of the distance from each x value from the mean squared times the probability of each of those happening. Then we're going to square root that to get the standard deviation. So first we find the variance, then we find the standard deviation by square rooting that. So we're going to start by focusing on this part right here, the squared distances of every point from the mean. Okay, so to do this in Excel, it's easiest if we start by finding just the distance of every x value from the mean. So this right here, this is mu. This is my expected value. I'm just gonna put that there. And so x is this cell here minus mu, which is this cell here. Now when I go to copy this down, I want C9 to stay C9. I don't want it to move. Like I want A5 to become A6 and A7 and A8, but I want C9 to stay C9. So I'm going to hit F4 on the keyboard not the keys F and 4, but there's up on top, there's the function keys F1 through F12 on your keyboard. We're hitting F4, and that will lock that. You can also just put dollar signs in front of the C and the 9. You can manually add dollar signs in there. And now when I copy this formula down, everything should work the way we intended. And we can check this. How far away is 0 from the mean? Well, it's 1.5 values smaller than the mean, so it comes out negative. How about 1? It's 1/2 smaller. 2 is 1/2 bigger. And 3 is 1.5 times bigger away from the mean. So now we're going to take those deviations that I just found, and we are going to square them. Now I don't have to go through finding x minus mu because I just did that. It's these values right here, right? This is x minus mu. And so I'm just going to raise this to the second power, and that will be my squared distance from the mean. And then finally, what I want to do is I want to find the squared distance from the mean times my probability function. Okay, so my probability that each value as I go. So what we're going to do is I'm going to take this value and I'm going to multiply it by the probability that this value happened. Copy that down. And then, so right here we have all of the stuff that goes inside here. We have it now. We multiplied the squared deviations by the probability that each squared deviation happens. And so now we're just going to do what this says, which is sum it all up. So I'm going to sum all of these values. This right here is called the variance. To find the standard deviation, we're going to take the variance and we are going to square root it. So I'm going to take the square root of the variance, and that will give me the standard deviation. All right. So what do these numbers mean? Well, if you remember from the previous unit, Unit 1, we know that the standard deviation, that values should fall within certain standard deviations away from the mean, according to different rules. We had Chebyshev's rule and we had the empirical rule. Now, the empirical rule only applied to normal data. So something that looks symmetric, unimodal, and the best way to see if we're dealing with data that looks symmetric and unimodal is to graph the probability distribution. So I'm going to create a histogram or a scatter plot. I'm going to change it to a bar graph, a column graph, and then I'm going to move the gap width to just about 0. Now, looking at this probability distribution, this is looking pretty perhaps normally distributed. So maybe the empirical rule would be good to use. But we can always use Chebyshev's rule if it's not. And so I don't have any questions to ask about that, but we'll do an example a little bit later where we will take a look at the distribution, determine whether it's normally distributed or if it's skewed. If it's skewed, we can use Chebyshev's rule. If it's normally distributed, we can use the empirical rule. But what you need to know for now is how to find the expected value and the standard deviation. I'm going to highlight these so that we know where they are. So this is the expected value and the standard deviation.